this part. So for the first bit, I'm gonna draw up some dimensions, and then the second part, I will take that drawing and I will transfer it into the app. So there's gonna be a brief interruption when we switch from one to the other. You'll see. This is my my camera cover. Nice. Now, clean up. This camera is actually going to be mounted. We're making a 3D printable mount that will attach this arm, this camera, excuse me, onto a robot arm, and the robot arm will then be able to wave the camera around and build a model of the neighborhood around the arm the same way that using like photogrammetry. Yes? Okay, so what else have we got here? We got my calipers. We got my favorite pen. We should be ready to go. Okay. And if I don't respond to your tweets and such, well, I do apologize. It's purely my fault. Let's see. If I move over this way, then everything should be in view. Oh, that's my microphone. There we go. Okay, so roughly speaking, we've got, I'm going to draw a rough picture and then dimension everything. And then when we know all of our dimensions, then we can take that into the computer. This is a much faster method, I find, than the alternative. So from the side here, we've got sort of like this, and like this, and like this, and like this, and like this. And then there's also a cross section of that, like this, where the outside is the same, but inside there's a lip in here. And I hope you can you see this in the dark? Maybe not, maybe not. So there is a hinge here, right? This hinge. There you can see it. It's in the light. Okay. So looking at it this way, it looks like this edge sort of comes like this. And then in the middle of it, there's going to be something like this, right? If I cut it right along this line in the middle. And then from the back we can see so this is this front, side, A, so this is A, and then back. I flipped it over, right? I don't care about what's behind the glass. It's not too useful to me. But you know what? I'll draw this detail in anyways, because when I put it in Fusion 360, I am a completionist. I play my video games all the way to the end, and I do the same thing with my 3D models. I put every conceivable detail in there. Now, this is just part one, right? So then part two, and it looks like the inside is straight and the outside. This is even easier if you use a whiteboard, because the whiteboard it's forgiving. You can make lots of mistakes on a whiteboard. There isn't a great way to model this that I can see, but we'll try. It's like I can position it this way and try to get both this end and that end, but it's not easy. I'd really like to fudge this hinge and make it simpler, but I'm not gonna. I'm not gonna. And I probably haven't left myself enough room for dimensions here. So I'm doing a one sketch once of the parts roughly, so I get an idea of what I need to look for, the details and such. And then I'll do them again each on a separate sheet. And that will be a different story. So and that should be right through the middle, yeah. Such a great center line. Are these the same size? Maybe, but I'm not going to draw them the same size because they might not be. Okay. And there's two more pieces on here. I have drawn the top of this wrong. This ball, though not very clear, it looks like the top of this ball is actually, it's like this, and then that part is straight. So let's get that a little closer into the light if we can. Can I bring this down here? And bring this up here right after I flip it open. Yeah, so you can see that connection in there. And are you actually looking through the lens? You are. You are. You are. There. So that's the connector on that side. And then we got a trouble guy over here. Oh, it's flipped vertically but not horizontally. And then this dude down at this end is another issue. Okay, so have I missed any essential details? Well, the curvature on this bit might be important down the road. So from the front here, I draw roughly the outside, and then this is about thirds. Yeah, and then this has some curvature to it, and I believe the outside edge is also actually curving inward. And I would bet that has to do with the way it's injection molded, but neither here nor there. Okay. Third piece, same profile, same outside edge. It's about half a unit. Okay. And there's 3, 4 units. 3, 4 units. So this is down here, and this is half a unit more. Straight lines. Straight lines. Then we get this bulb here. This pill-shaped thing. And that sticks about halfway off the far edge there. In fact, it's less than that. It's 1/3 of that. Right? These two outside edges are part of it, and the inside is this piece, which is this piece. Right. So this goes onto here. So this is. The centerpiece is here, and this bit. So this is not a line, right? but this line is a little bit inside there. I wonder how they put that together, because this is one piece around both sides. So how did this snap in? I bet there's spring-loaded pins in here, and once it's put together, they snap out, and then you're stuck with it. You cannot get that apart, is my suspicion. Oh, I see. There's a seam here. It's actually more than one piece. The top edge of this piece is separate from the underside. But for my purposes, for modeling this, for putting it together in the machine, I think I'm going to cut that corner. Yes, I am. Yes, I am. Okay. Then. So here-ish is this line, and then there's curvature on the back, and then there's the center cutout. So if I draw this center line through here, why didn't you use the ruler? Look, cut me some slack. And that's rounded, and that's rounded, and these taper outward ever so slightly. I bet it's 5 degrees. And there's a screw here and a screw here. And on that back is a line and an oval and the plug. And I want to know the location of that plug coming out, because I don't want anything to block the wiring. Easy enough? Easy enough. Okay. I'm going to forgo the texture for the moment, though we may revisit it once we got the rest done and we want to beautify this model. Okay, looking around here. Oh yes, that's very important. This is the back of the piece, yes? No, that's the other piece. So the back of this piece. And now we're back to using the ruler. Okay, whatever. Not a terrible impression of it, yes. So there's that center line we were talking about, and we've got a cutty thing here. Maybe if I drew them the same size, that would be good. There's the cutty thing, the cutout. Okay. Then here-ish. This comes like this right up to the edge of the. So really, this is this big. Yes. And then here, we've got a screw hole. Okay. Now, last piece. Last piece is straight line. This actually flares outward, right? Exaggerated. And if I look at this from the side, and this is up and then straight. And there'll be a hole through here. Okay. I'll have to revisit and see if there's more of this later. I should have done this on a separate page instead of there, but instead of what I'll do is I'll draw them out here in my trusty slightly moist binder, and we'll make it work. So let's do that first. Get you out of the way. weren't terribly helpful. Okay. So once again, rough sketch. Centered. Overall length. Wait, this is zeroed? It is, and it's in inches. Haha. 93.8. $28.8. The curvature at the top edges here, 89. I guess I could say 90 and round it up. $55. Hey. $61. Okay. And then from the side, this actually flares a little bit, so I'm going to exaggerate this. This curves a little bit. This is very, very flat. This has a seam line. This has a little bit of a curvature in the model there. At the front, the height we already know is 28.5. At the back, approximately 26. Thickness in the middle, 24. I guess I could do a drawing like this, but I guess I should do a drawing like this. And how do you trace this curve, right? Ugh. See, because I slip. And if I slip, drawing is no good. We know this is 93.8. We know this is 26. Not 26. What am I saying? It's 24 in the middle. 24. See, I'm making the mistakes here instead of fighting in Fusion to get it right. Vertically, here-ish. I press flat against this side, and then I only touch to this point. That's not really helping me. This is from here to here is about 23. I don't have really a way to measure these radii. I don't have a circle measurement tool. Ugh. Okay. And then the back. Has the cutout. And I will assume that cutout is centered. $45. And the interior down here, 22. Right. Now we also have this wire location. This wire itself is 2.7. Maybe even 2.8 to be on the safe side. And approximately 16 to the edge there, not to the center. This is an ugly curve, an ugly line. There isn't a great way to measure that, but it is approximately 30. Okay. How about, yes, so the cutaway section in the middle here. We just did this direction. I'm going to draw it this side. There's the flat front. There's the slightly curving back. Can I see in here? It looks to me like there's actually two things going on here. So this line curves much steeper downward. This line curves much steeper downward. And then there's a line here somewhere, and between the two there's a curve, and then the round bit from the other sections, from this round piece right here, comes inside. There's this pockets. There's a round pocket, something like this, right? And these two lines probably line up. And the difference is that the room to move is what gives this the ability to rotate. So in here, there's actually there's a pocketed area. If that underneath. So measurements. 9.6. Two point three. That's still 22. I can't really measure that angle. I can measure this height approximately as being 5. Is that enough to model that? I think so. I think so. Okay, so the next piece, and we got the whole sheet here to use, right? So let's not be shy. It's got a flat top, and then the inside is straight, the outside is curved, and there's a lip here. And there's really a lip because the inside has this padded foam on it, and the outside is something else. And there's a moment right about, this is huge, so right about here, this wall comes up, as we discussed, and there's a circle here. And it really looks like the center is right on the line with this. This is all on the same line. Now I have no good way to measure the size of this circle, but I can infer it from a few other measurements. Like, actually going back here, this edge is also 5. So knowing that this is 24, this is 9.6, and this is, so if we say this is 15, then this remaining must be 10. That's, we had 24 up here. 24 minus 15, 9. Right? So this circle is probably 9. And that means that this is probably 8.5. The distance from here to the edge is 6.1. From here to here, 6.1. I bet this and this, the angle is 5 degrees again. Thickness, 6.4. Length, 58. This has a curve on the bottom. Yeah. Um, Oh, so then there's this bit, right? With this sticking out of here, and this. Which side is on the? This is on the inside, right? So this is part of this, as drawn previously. So we know that one's 22. This one is 16.5. And I can actually get the diameter here. 9. And I can get this measurement, 3.8. I believe that's on the center. So the taper, right? At the outside edge of the front here, it is 45. At the back edge, it is only 40. And I don't have a really nice place to draw this, but it's basically a curvature. Yeah. All the way along here. It's hard to say what kind of curvature. It's hard to measure. So because part of it is hidden, and I don't want to take the whole thing apart. Thickness, I think we covered that, is 6.4, 6.4, and it looks like the ball here, although it's 9, it's in the middle of this. It's in the middle of this line. And then it comes down more than that, because this would be half of 6.4, which is 3.2, but this, as we know, is 9. So the middle is over here, is off center. Okay. No other distinguishing characteristics on that part. Next, another tapered component. Do I need all 4 sides? I guess I do. So we're gonna have 1. We're gonna have 2. 1, 2, 3. Sure. Three. And I can't really see under the 4th side, but I can infer. There we go. Let's try that. And from here, Yes. And we're also going to need this way. Uh-huh. Okay. So top view, cut, line. This is rounded. This is rounded. Screw hole. About here-ish, about here-ish, about here-ish, about here-ish. There's the center, right? About here-ish with a rounding. That's all. That's across one line. That's rounded. Yeah, and the bottom edge of this curve is the middle, and the bottom edge of this is the middle of this circle, which we established is 9. Thickness at this end is 11. And thickness just before the dip is still 11, so that's straight across. Thickness in here, 8.3. 8.5. I like roundy numbers. Yeah, there's not a great way to measure that. I could measure this down, which is 20.28, and then measure this down, which is 4.8. 15.42. I bet it's 15 and a half. I'm going to say 15 and a half. So from here to here, 15 and a half. This we established, but we're going to measure it again. It looks to be 17. What do we have back here? We had 16 and a half. So if this is 17, then that leaves a little bit of clearance. That's fine by me. So this to this is 17. Outside of this, 32. Outside of this, 41. Outside here, 44. Inside here, 18. Depth this way, 9. Edge to edge, maybe approximately 25. This is a quarter 20 bolt, I know that. quarter. I should write it the usual way. Quarter 20. Quarter dash 20 threaded. Depth 5. Let's compare with. Can I measure it off of this line? Not well. But I get something like 8. And I can compare these two numbers with whatever I get for the center there to figure that one out. Okay, so that's this side. Then there's this side, and we've got, that's the lip line, right? Then there's this and this and this. We've got all of those numbers up here. This line is the same as the screw line. The screws are centered about 7. On both sides. I have no idea what this type of screws these are. These are, I'm betting they're M2s. But I don't know. Okay. We can't do much about the curvature here, but we can measure the thickness. I think we have this number. Oh, we don't have this number yet. Yeah, we do. It's 11. I've got it right here. Ha 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 ha. I would bet this curve is R5. All the way down. Handy for releasing it from the mold. And on the other side, what do we need anything here? Are we missing any numbers? I guess when we put it in the computer, we're gonna see which bits it says, you didn't put a number here. And we'll come back to this drawing and finish it up, yeah? Okay, so last piece. The last piece curvature. And then there is a curved piece in here. And if I turn this piece, yeah. So the height back here is actually really, because that stupid lip is in the way. Can I measure down to the lip? Definitely. 6.1. From here to here, 6.1. ID here. 18. We established that before. So I measure twice. Measure twice, cut once. I want to believe that whatever that roundness is, it's the same. It's the radius. This looks to be that looks to be 6.7 for measuring it this way, like this. Yeah, it's mostly eyeball, I know. It should match 8.5. Okay, dokie. And out here at the widest point, and we already established this is, whoopsies, 20.7. Yes, 20.7. This is the top, this is the back, this is the front. Something like this, yes. Perspective view. And I do believe there's a little mark here. Cosmetic mark, possibly left by the injection molding machine. What else? Little curve there, right angle here. This looks like it's probably 15 degrees. Maybe more, maybe 30 degrees. Not a high confidence level on there. Height of the groove itself is eyeballing that from the side. Eyeballing this tiny little curve. Here, bring it up here so you can finally see what we're talking about. Yeah, that little curve on the edge, on the lip. Okay. I'm sorry I can't bring the camera lower, but then, yes, other problems would occur as a result. Okay, so we might We might have everything now. So we're going to model each of these components. We're actually going to model them. So I'm really tempted to model them all in together as a single assembly. And that's easy to do, but then comes back to bite me later if I need to tweak some of these numbers. Or it can cause issues. So now we are going to take a, you're going to see an interruption in the video. We're going to swap over to Fusion 360 and we're going to copy all this out again in the computer, and hopefully we do a better job. So stick around. I'm going to take my calipers and my camera with me, all this good stuff. We're only moving 2 feet over, but that's how it goes. Okay. Pictures of dogs. This is my whole music. Fly with me now. The beautiful sensation of flight. Yes, you are upside down. Hold on. Relax. I'm with ya. Be right there. Fusion. Nothing interesting on my desktop. Typical. Hello. Good, I am being received. Most excellent. So gang, I've got my drawings here, as you saw, and we're going to try and make this work. End effectors. So I actually have a 2-finger chuck gripper, this one, and this part. This is the part to which I want to attach the camera. The whole point is I'm modeling the camera to be here and then connect a 3D printable part between the two that will hold the camera in place so that the arm can then have both a gripper and a camera. It is a multi-function tool. Nice. Let's make this instead of putting this in the chuck gripper, because we might need this camera later. Yeah, I will keep it in here in end effector tools, but here we go. We're going to save this as C920 web camera. And I want a new component. This is the sure. And the origin of my part is going to be the center of the face of the camera. Yes. Mirror this, no, not that, and this. Oh, I don't have a mirror line. Grab me all of this except this, and then mirror it around this line, please. Excellent. Now, according to our dimensions, between this and this is 28.8, and our radius for this is 61, and our radius for this is 93.8. It's a funny number, but there it is. Both of you are concentric, and both of you are concentric. And of course the mirror copy jumps to match. Very, very nice. I may have to, so that the curvature from the other direction is going to be super fun. We may do it as blocks because I want to do it right, but I also something like this. So there's one that we missed. What is the size of that lens picture? That lens right in the center? What is the size of that? That is approximately 6. And has an estimated OD of 10. Hey, now. It's mad that this and this are tied together. There we go. And this is 10. So I had to deal with some constraints there. Okay, there's our outline, the front of this device. I'm going to extrude the shape in both directions. Firstly, this one. In 2 directions, symmetrically. And the total distance will be the thickness, which we established is 24 in the center. And then show this sketch again. And extrude these. Extrude them symmetrically. The total distance on the ends. We said 24 across the board because we don't really know. I'm going to say 23, just so that we get that lip there, and then we can go on this side and we can cut into it, right? And I guess lastly, extrude this 2 sides, this way right to the back, and this way stop a little bit short. So there's a rough outline. If we wanted to be really, really safe and leave lots of tolerance room, that would be a good way to do it. Whoa! Don't drop the camera. Okay, now I have my origins here, so I can say, you know what? I want to take this this center line here, and I want to construct, inspect, section analysis. Okay. I also want a new sketch on this line. Excuse me. I want it this way because that matches what I've got in my drawing. Okay. I will project this edge, and I'll project all these edges really. Okay. I had established in the drawings that it's 28 at the front and 26 at the back, so it's tapered. So let's go back one here, and this, if I draft this, say this is drafted from pull direction, and the faces are this and this, and I say it's 5 degrees. Oh, I want -5. Okay, so this height from here to here is 28.7, and from here to here is 24. That's almost right. So that draft angle, I can edit that. Let's say it's 3. From here to here is 26.2. I'm happy with that. Okay. So there's my sketch line. Don't do that to me. Stop doing that to me. There is a curvature on the back. I don't know what this curvature is, but there is some curvature. So I can make that a pretty big curvature, whatever. There's some curvature there, then there is this edge, and then there is the cutaway underneath it, right? Great. Now, did this project to the 20? It did. I wanted this one. Thank you. There is a line that comes up like this. There is a circle in here. I said a circle in here like this. And then somewhere there's a line that probably comes this way. Right? Let's do that. Let's do that. Let's do this and this. I'll just leave it as a solid line. I'll just say cut all of this. Okay. And that section under here, so this line has a height of 2.3. This has a radius of 9. This front edge from here to here is 5. The back edge was measured how? Oh, it was measured along that edge. So from this point, if I make this a construction and then I put a real line from here to here, I can actually get the Nope. I'm gonna have to go from here. Give me from this to this. Give me this. Yes. That's 9. And oh, look at that. It automatically did that for me. How convenient. I believe that's a straight line, but I don't know for sure. I bet now, looking at it, that instead of being parallel, this and this are tangent. Okay. Okay, now it's all still blue because it's all still movable. And so if I say this and this are coincident, then I guess the real question is yeah, well, how big is this curve? Let's lock that in as a guess. And what's left to move? What's left that can wiggle? Just this? Just this? Okay, but we established in our drawings, back here that the height from hello, ruler, distance, from this to this, from this point to this point, is 5. Well, that don't seem right, because that line is now pointing down. And I can see from looking in here that it's actually it's pointing up. So I would question this 2.5. It's more than that. It's more than that. There's a line that comes this way. The center bit, right? So how am I trying to put this? So let's take a look in here. If you can see, yeah, when I turn it into the light in the right way, you can see there's the center section is part of the outside edge. Okay. And the center section is what I measured on here. That's 2.3. This line is 2.3. And is parallel to the bottom. I do believe it is. But this back, there's a difference of 5 degrees there. So if I take this away, hello, if I take this away, whoa, and I say U to U, you're 5 degrees, well, everything locks down nice and tight. Will it work? Will it blend? We're not too sure. I need to close U. And I need to close U. All right. So, oh, and there's a little bit of U. A little bit of Monica in my life. A little bit of Sheena by my side. A little bit of Tina's what I need. Symmetric. All. Cut. There's some of my curvature started. Take this and does this cut all the way across? This cuts all the way across. This is cutting 2 sides symmetric for a total distance of 45. 45. Okay. And we keep the middle section and then cut the 2 bits outside of that. So we're gonna do first this. We're gonna do a cut and then we're gonna put it back in again. Or, even better. We will do the we will do an offset. Our offset is half of that center, so that's 11. And then our distance is 45. So 45 divided by 2 minus 22 divided by 2. Oh, fine. Same thing. Whatever. Analysis. Hey, I wanted both sides. That's one side? You know what? That's fine. That's fine. I can just mirror it. Mirror on the mirror plane, which is this one. There's my shape. That's what I want to see. Okay. 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 Now we're getting somewhere. Looks reddish. Am I missing anything inside there? No, I don't think I am. I mean, I can do a bunch of little things in there, but I don't think it's necessary. Give me that back view. Give me this sketch. I really want to put this curvature in now, but I don't know what this curvature actually looks like. I do know a few of these dimensions. For instance, I know that at the edge of the screen, which is 55, so this is 55, and then this, at that edge, we measured it as 23. So it didn't change much from the original. Actually, I should not have tied this. I should not have made that on the origin. Hello. Because it's not on the origin. It's this is 23. This is 55. This is on a line that is constrained to the center, and this is projected. Okay, and this are collinear, right? The back is chopped a little bit, and it doesn't show up in here. Maybe that's part of why my dimensions were coming a little funny. So then from this corner, it's going to come down a little bit, and then it goes out a little bit, and then it comes around a little bit. I'm not sure how far down, probably halfway. This line and this line are tangent. And at this point, when they meet on the edge, they're very, very flat. It's this end that needs to come in. And oh, isn't that fun? So it's more than one curve. It has to be. Maybe 3. Do I like that? I really should take a picture, load it in the background, and then match the curve. That would be the smart way. That is a new body, definitely a new body. 2 sides, symmetric. That is a new body. This new body, I will mirror. And then the 2 of these I will intersect. Needs work. But it's not terrible. It's just yeah. So we got the shape. We got the shape. I'm pleaserished. There isn't a nice way to fill it like that. I mean, there isn't a nice way to fill it this way to make that round front more roundy. Camera body. New component. Section A. Because I don't know what this is called. All right. From the same construction plane. No, I can't even look in there. From the same construction. There we go. Construction plane. Oh, it's going to do that to me every time. We're not turning the page. For review, here's our part. And we are going to have to make this, you know, technically this, but then also flip it this way. Because, you know what, if I do this, like this, right. So, from where you sit, it looks like this, right? The round bit in the corner, is going to fit in that hole, and it will match up with, my view is always backwards. Okay, it'll match like this. Okay, cool. Big breath in, big breath out. And away we go. We said that this line will come right up and hit here. Yes. And there's a line that comes straight across here. That's a construction line. But from this imaginary line to this point, from this point to this imaginary line is a height of did I miss that dimension? Seems that I did, boys and girls. And aliens in the distant future. 15.2. The thickness at this end is barely 1.3. And at the other end is not very measurable, except that I know I have one number that says there's a line that comes down from here and comes down to here, and that this point to this point is 6.1. Okay. So I've got a construction line that goes this way, and then I have a real line that continues out this way for quite some distance. Where did you go? You come over here, and then you come all the way back to here. Yes. I didn't need to go that quite so far. The thickness here. So this and this are parallel. This and this are parallel. They have to be, because there's a T here, there's a T here, and there's a T here, and there's a T here. There should be. If I can I over constrain it by doing this? Yes. 6.4 was my measurement. And this way from 58 from over to here. So from this point to this point, 58. Fantastic. I'm pleased with this so far. We're going to extrude this and then we're going to taper it. Yes? Yes. Oh. Give me that circle. From here to here, please. I don't know why when I put the two circles together, it insists that they're not. Okay. On the one end, there's a cutout in the middle. Yeah. So on this end, the whole thing across is 45. And I want this to be symmetric, total distance, 45. Right, and I can look at that with the camera body there. Doesn't that look nice? It does look nice. Thank you, I agree. There's that front section. So from this line, I'm going to split the whole shape, yeah. And then from that taper, that draft. So I want to draft from this direction, and I want to draft this face and this face. How long is this now? This is 35, and we want it to be 40, so it's less than 5 degrees. Let's try 3 again. 39.56. I'm good with that. Now we've also got a fillet on both of these, which is probably a 5. Looking at this curve, I'm guessing it's a 5. And that goes all the way to the end, yes. And if I bring back my sketch, whoops, I bring back the sketch and briefly hide this body, I needed this line to be non-construction. Which is, thank goodness we can go back and edit, hey? Can't do that in SketchUp. So our shape is still there, but now we can take this and we can cut away symmetric total distance, and that interior cut, as seen in the previous sketch, cannot be more than 22. So I'm going to say 21.5. Oh no, it has to be more than 22 to make the part fit together. 22.5. Okay, so when I display these two components side by side, you see they fit one inside the other with the teeniest amount of play. So I've got the bottom lip, I've got missing the ball on the end. Yes, 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 yes. Edit the sketch, and back here, the ball on the end probably lines up to here. And then there's that circle, which we said was 9 diameter, and we measured, there was a point here, and from this point to this edge was 3.8. I said 3.8, not 3 divided by 8. Okay. And then lastly, I don't know how oh, see, why is that? Thank you, Fusion. Now I need one more extrude from this sketch, and it is this, and it is again symmetric, total distance 16.5. That's looking pretty good, pretty good. This curve on the front, so if I say, I'm going to hide this sketch, I'm going to hide this part because it's confusing. If I draft again, if I draft from here, and then I select this side, and I select no, and I select no, no, 1, 2, 3. Oof, oof. It doesn't want me to draft. What I really want to do is draft from the top of this circle downward. But maybe the best I can do right now is to draft from here, and then draft this and this. Like this. And I realize these two parts are going to collide, but I don't have a better way right now. Yes, I do. Yes, I do. Don't be lazy. I can split this part and then put it back together. Split these two pieces, please. Then draft from here, this face, and this face. Good. Then put all these bodies back together. Combine, join. Okay. Best I got for you. And then this and this. Let's try a 5 because that's what we did before. That looking good to you? That's looking good to me. Okay. So here's my 2 components, and if I go up to the root, we can see, okay, I've got one and I've got the other. Is that from this piece? I don't know where this particular drawing came from. This is from here. It is from here. I had 3.8 here and 3.2 here, which adds up to 7. Well, that's almost 6.4. It's pretty terrible measuring. And I'm not sure how I got. See, because that's 3.8. That's what it should be. So I'm not going to worry about this because this seems like hooey. Okay. Next component. All right, boys and girls. So we've got. I'm going to turn it for your benefit. We've got this bit, and now we've got this bit, and now we do this bit, and we're gonna model it. We're gonna model it. Question, do I model it this way or do I model it this way? I think I model it this way because that's actually where it's going to be. I'm fairly certain that's where it's going to be when I put it on the arm, so it saves me one step. I need a new component. Oh, I can't spell. Okay. Ooh, that's fun. I missed that. If I go back one. So this circle that we had in here. I needed more of that. That's all I can say about that. Symmetric total distance. That is the outside dimensions. 32, 32. Total. Cut. Then roll this all forward again. Okay. No, it doesn't like that. Didn't want me to do it that way. But I needed to leave room because there's the two outside parts of the hinge, right? They come inside this other piece. That's what that room is. And they're pill-shaped for some fun reason. Maybe I go back to the way things used to be in the good old times. Were they good? No. Were they old? Yes. And then go back to my section B. Okay, now we will continue from where we were. We will model this part to go inside the other part, and then we will use one part to cut away from the other part. You will see what I mean in a minute. Okay. Thinking about the best way to do this kind of makes me nuts. This is an easy way to do this profile. Sure. Let's go from this. See how we do. Okay. I'm looking at this away to try and make sure I get this right. Even though I have my diagrams, I want to be on. If I model it closed, I might actually have more success. And then I have to hinge it and move it around and all of that stuff. So, looking at it this way, I have a line going down this direction. I have a line coming out this way. I have this. It's not centered, no. I have a line that comes up some distance, goes in some distance, comes up another distance, comes above this line, and then comes down to it. You are collinear. You are probably at right angles to each other. And then based on the dimensions that we put in here, this is 11. 8.5. Total length of this part is missing. My calipers are zeroing out a lot today. I can only assume that I'm electric. That's what she told me. And the amount of offset from here, that's a great question. It is whatever this distance is from here to here, it's about half of that. So if I project this point and then I measure this, that's fine. This to this is this divided by 2. Everything locks down nice and tight. Okay. So now I can extrude this, and on the outside end, on the fat end, it is 44. Yeah, it is actually a little, just a whisker more. See, because this is the narrow end that I'm looking at, but the other end, the fat end, is 44. Oh. Okay. I can even go onto here and say, hey, this edge, excuse me. So from here down to here, this to this is half of 40. Mirror around this line. Okay. And then cut these two away. Just throw them out. I'm only cutting one, right? Yeah. So there, that was probably easier than a taper. I know it was easier. Since I'm throwing stuff out while I'm there, I can also come in here and do the, it's not really pill shaped, it's a box with some some rounding on it. From here and something like this, and where am I? No, give me dimensions. This is 18, and this to this is 9. That's not 9. The circle was 9, but the cutout in the center is not 9. I've already got it modeled on the other piece. Don't I? Oh, I wanted to cut on this end. Right. That shape. So we're actually going to cut that away. Then we're going to say this part, the tool body is this part. Cut. Keep the tool, please. So now this has a nice slot cut out of it. And I'm gonna make it a little bit so there's room to breathe. Yes. And then there's a pill shape on the end. Just these pill shapes here. And that would get annoying, except that I think I have a solution. Which is to take these two lines and use the slot, center to center slot. So that center to that center, and it is this big. And then from here, I need a center line down which it says closed, so that when I make a revolution, as you're about to see, I use the revolve tool. The axis is this center line, and I want to join with the piece that I'm interested in. Yes. There's my joinery. And then in my section A, I will cut this and keep the tool, please. So when I go back to the root and I look at these two components together, this has been cut from this. Like so. And I can cue each of these minus. So that gives them a little bit of extra room. And we're starting to look a little bit, that's looking a lot like the pill-shaped end piece that we've got, with the comfortable slot and all of that business. There's no tolerance between, at this edge, there's no gap here. I'm gonna live with that to the end of my days. Okay. So then we have fillets. 5 seems to be a very friendly fillet around here with this, whoever designed this part. And looking at it from the side, I can see that there is a fillet here and a fillet here, maybe less than that. And at the on the tail end of both of these, actually. So this yeah. And I'm gonna leave this, I'm gonna put the fillet on this end later because I need to make a cutout first. So when I drew this interior sketch, I should have also added that there is a cutout through here, and that cutout is claiming to be 9 deep. Yeah, that's the 9 I was looking for. And that's 18 wide total. Yeah, this slot here is what we're dealing with. I know there's 2 screws modeled on this side. I think I can forego them. However, on the back side, there's a line that goes from the middle right up, and somewhere on this there's a center hole with a circle that we said was 9.5 in diameter, and from, I measured the inside edge of those circles. That's silly of me. From here to here. Yeah, I think my battery's getting low. That's why it keeps zeroing out. I've said that before. I'll say it again. From the edge of the circle, get you on the line. From here to here to here, 23.7. I'm going to remeasure that to be on the safe side. 23.1. And on the other side, it's about 6 3/4. Yeah. Yeah, that's about right. Okay. All of that is in service of saying this is a threaded hole with a little chamfer on it, and this is an ISO, no, this is a Acme quarter, just a standard quarter screw, yes, and the outside edge of this is not 11. There is the very faintest of chamfer on the inside edge of that hole. And as we can see, it is threaded, but I made the depth too much. So the depth of this hole was -5. Total depth of the hole 5. There we go. It's a flat bottom. It's not a curved bottom or a taper bottom. This bottom is wrong. It's like this. So we've got the roundy bits on the outside. We've got those roundy bits. I put those 2 points here, and that might be wrong. This line is in fact good. Oh. Distance from here to here is 32, and it should be concentric. So I don't have a midpoint. I don't have a midpoint. Hello, hello. Oh, joy. Okay. There we go. That's what I want to see. And notice it updated everything else. Beauty. Last, I'm gonna fill at this end now. I can't wait any longer. This pleases me. Okay, and finally, one more new component. I don't know. Maybe that should have been the parent. I don't know. That is the right location. Get rid of that, get rid of that. Flip this over. Last page. Final boss. I would like to project this curve so I have that center point. Ooh, but that center point is not, it's clearly not going to be the center for this thing. Well, I based that curve on a guess, and there's no reason to believe that that is the correct position. Let's try this from a different direction then. Okay, we have, roughly speaking, we have a rectangle some distance, and then we have a parallelogram some amount, and we know that this, we know some dimensions here, go away. We know this dimension is 2.7. Hey, now we know that these two dimensions, we don't actually have a measurement of that thickness. Ha ha. It's 2.75. We're pretty sure that this is 30 degrees. Excuse me. We know the overall length. It's very close to that. This seems too big because this and this are basically flush when it folds in. That's probably bad. That's probably bad engineering. So far, it looks all rightish. Whatever this circle is in here, it doesn't reach the bottom. It's something a lot like this. So then there is a line that is coming out of here and going up to here, and there's almost certainly a mirror of it that goes this way. The base of which I can't measure with the calipers. It's not going to fit through there, and there's another part in the way. But we measured this circle at 8.5. So this could be like this. This might be tangent to this. I'm going to say yes, it is. And this and this. But also they are symmetrical. This and this are symmetrical around that. And I measured this to this. Here I have 2.6 and there I have that measurement is, I couldn't get that because it's too small, but from the other side I should have measured it, and it is 8.2. Well, now that gives me, hold on a second. Still 8.2. I guess a great question is, how did I measure this 8.5 curve? Because it actually, I stick the tool in here and I try to get something. It's more like 6.5. And that would be why this is not tangent, because this is down here, which is where I said it would be. The height difference is very small. It's something akin to, but not exactly, 1. Six, sure. So this is half of 6.5 plus 1. Okay. All the numbers seem to say that they're in now, so I can finally extrude this part and then do the drafting sketch, and we're nearly there, ladies and gentlemen. So firstly, let's say this one first. We extrude this symmetric total 17.5 so that it fits in the room that we've got. Great. And then we take that same sketch again and we extrude this and we go the full size, which is 12 on the small and 13.3 on the big. Nope. My system may have reset itself one more time. 43. 43. Not 13. Favorite pen, come back here. 43. Symmetric total size. What was the outside? 44? Let's try doing that. Okay. And then from this direction, we'll do that cutaway thing again. So there's a line coming this way. And then some kind of a circle on the edge here for that rounded corner. And from here to here, it's 42 divided by 2. Yeah. Good. So I now cut away from this and I mirror that. There's my foot. So I now have my camera, the holder, and the foot and the screw all attached. Yes, yes. Crude, yet effective. All right, now hide some of these origins that I've left exposed. There we are. Let's apply plastic, opaque, black to everything. Nice. Now, back in our 2-finger chuck gripper, I'm gonna save a new file. It's a camera adapter into which I bring my 2-finger chuck gripper. And my webcam. Because I'm missing the rest of the arm, I don't know if the bottom of this finger is actually going to clear whatever is around the arm. And there's now a height difference of less than a millimeter. I think I'm gonna get away with it. Now I want to use the screw hole that's back here to hold this piece on, and I don't think I can. So I think the next best solution, see, now if this had been modeled closed, maybe I could have gone all the way around. And that means all the screws come from this. It doesn't come from the same direction, but it's pretty darn close, and the modeling is nice and easy. Oh, foo. So I've really got to make joints here between these various bodies. Let's see. As built joint. First off, before I do that, let's say this camera body, this is grounded. It's not moving. For the purposes of, oh, okay. Maybe we just say section B is grounded. Assemble. You're ground. Okay. I don't believe these are centered on each other. as-built joint is a revolute joint, and the components, this component and this component at that point of rotation. Yeah, but I want the other piece to rotate. So from this one and this one and that point of rotation. Perfect. And I will add some limits to that later. So then on the other guy, the as-built joint is from this one to this one, and the point of rotation is here. Also perfect. And then lastly, an as-built joint from here to here around this point. Perfect. Excellent. I can hide all those joints now. Save that. Come back into here and update it. You're updated? Good. You're going to be closed like this. You're going to stay where you are. There's not much that's actually stopping that from tipping over, which would completely mess up the measurements. Just the friction of its own position. We'll deal with that a little bit later. Okay, so now I want a new component. And am I starting on this surface? I think I am. No, I'm starting on this surface, and I will work up from there. I would slide the camera further back, but then it would actually block the holes. And I need those holes to be accessible when the screws come out so that I can print the thing that goes around everybody here. So we're going to project you, and project you, and project you, and project you. And how about a line that goes from here down to whatever the middle is? I've got a line from here to here. That's my midpoint right there. Right? And I've got a line that goes out to the center of whatever this is. Or project this one as well. Line, please. I want a line that goes from here down. And then I want a line that comes from here and goes out, and these two meet. Yes? Yes. Now this, and you are mirrored around you. Oh, you know what? We can also add you to the mix. Okay. Okay. So now I can extrude this and this and this and this. I can extrude all of this actually. All of this up to this surface and then go another right, but then come back and say, oh, actually I need you to take all of this away from me, please. Go up to here. And I only want you to cut objects to cut. Yes. I only want you to cut that one part. On the previous extrude, I missed one little piece. This little piece. Okay. Oh, I missed more than one. Still fixing. This is the problem with mixing solid and construction lines. I mean, if you make only your profile construction, you don't have to go back and find all these little shavings. All right, and as I recall, this inside edge was a 5, so we're gonna fillet it for a 3, which is less, but that means that they don't interfere with each other. And still adds a lot of strength to this shape. So this is going to sit around both halves and screw into here and hold the camera steady if we're extremely lucky. This is gonna, the screw is gonna bite into this plastic, or at least it should. What's the diameter? 1.6. It might actually be a loose fit, so the screw would go right through. I want a polygon. I want a circumscribed polygon, and I want it to be a diameter of 6. Oh, that's the radius, so diameter, yes. Yes. See, this is a nice idea, but now I've got an underhang and then my print gets ugly. So let's not do that. This 1/4 bolt, I want to bring that in. To get it as close as I can for a better hold on the part. And I think this corner and not this edge and not this one. Edge, please. Okay. So looking back at the big picture, we have a holder here now that screws into the same 2 screws from above and holds this camera here. And we may have to do a few things to lock these down, but for a first try, not terrible. Maybe not terrible. We will attempt it and see. I wonder if it would be worth putting a bar that comes from here and goes backward and touches on this edge. And then it can't shake. But this is a test it and see scenario. That's what this is. So that fillet, I want to make that even bigger just to be on the safe side. Okay, so that's definitely going to need some locking down. So I mean, a little slip of paper in here or something to shore it up, to tighten the gap. It's the web camera I've got, not the web camera I want, but I hope it's enough. Okay, so I'm going to now throw that in the printer, and then I'll put it up on Instagram, and I'll let you know. You can all rewatch this if you like. I hope this has been fun. I've certainly had a great time. It's been Dan, martinclever.com. I will see you next time.